In this video, we're going to be talking about the concept of scope, which has to do with where you're allowed to use variables that you've declared. So when you create a variable, when you declare a variable, what you're doing is you're making a connection between a name and a value. So if I say int x equals 4, what I'm saying is the name x is connected to the value 4. And now where's that value 4? Well, it's stored in some memory location. So really there are kind of three things that are connected here. X, the value 4, and then some location in memory that's holding that 4. So X is kind of connected to the memory location as well as the thing that's stored in that memory location. And the thing that we call the part of the program, the region of code, where that association is connected, is called a variable scope. Now, there's some obvious places that aren't part of a variable scope. So for instance, the line before you say int x equals 4, it's not allowed to use x. X hasn't been declared. So the line before the declaration is not part of a variable scope. Now, where scope is very important has to do with blocks. What is a block? A block is a region of code that starts with a curly brace and ends with a curly brace. And you've seen blocks in many different contexts. Every function you've ever wrote has blocks in it, including the main function. When you do while loops or for loops or do while loops or if statements, that have blocks with multiple statements, like if, something in parentheses, open curly bracket, that is denoting the beginning of a block and it ends when you put the close curly bracket. And when you declare a variable within a block between these curly brackets, it's only valid until the end of that block. Now, it's important to remember that if you declare a variable in a block, after the block is done, that variable no longer exists. That memory is no longer accessible to the program. Another important place where we need to talk about scope has to do with parameters. So when you define a function, you have that parameter list that lists, long parameter A, int parameter B, separated by commas in their function definition. All of those parameters have the same scope as the body of the function. So, and that makes sense, right? If you declare a name in your parameter list, it can be used in that function, or else it would be kind of useless, but it can't be used outside of that function. So this is really important to know because when you're returning information from a function, like you're returning, the answer, you need to make sure that you're passing back information that will exist after the function is done running. And this will make a lot more sense when we're talking about more complicated data types, especially when we start talking about references and pointers. We'll get to that in a little bit. But it's important that the thing that you're returning from a function, that you make a copy of. You make it something that will exist after the function is ended. And once again, this is really more information that will make more sense when you come back to it later. For the sorts of functions we're going to be writing early on where we're just using fundamental types, this doesn't actually matter. Now, one thing that can get kind of confusing is that functions and programs in general can have multiple scopes. You can have nested blocks, where you have your main function, and inside that main function you have a while loop, and inside that while loop you have an if statement, and inside that if statement you have more and more blocks. Now, within each block, you have your own variables that you're allowed to use there. And those blocks can also use the variables that were declared before that block. But once again, any variable declared in a block, once it reaches the end of that block, then it's no longer accessible. And this will make a little bit more sense when I show you an example. But the important thing to note is that you can actually have multiple variables with the same name in the same program as long as they're in different scopes. So for instance, you can have int x that's in one function, and you can have an int x that's in another function. Those are completely different x's. They don't have any association with each other. And you can even have multiple x's within the same function, once again, as long as they're in different blocks, as long as they're in different scopes. So let's switch to an example. Okay. In this code, what we have is a function. Well, I guess to begin with, we have some includes, but then what we have is a function called my_root, and it has a couple of parameters, and we have the body of the function right here, and at the end here we have another function, the main function, where we're calling that function a couple times. Now, the important thing to notice, let's look at when we declare variables, where do they exist? Well, here in our parameter list, we're actually declaring two variables. We're declaring a variable named value and a variable named epsilon. where's the scope of these two variables? It exists for the extent of this function. So the name value is valid through the entire function. You can see it I'm using here at the beginning of the function. I'm using it here within another block. Do you see the block that starts here and ends here? And I'm allowed to use value in nested blocks. Epsilon has the same scope as value, and you can see me using it here as well. Okay, this hopefully should be pretty intuitive. Pretty much all languages work that way. Okay, multiple choice question time. Should you reuse names in different scopes? Okay, well, let's make sure that we understand what this question is asking. What does it mean to reuse a name? It means to have like the variable, the name X used in multiple places in your program. Does it make sense to use the name X in multiple places? I would say, well, it depends on the name. Like, using the variable I when it's for a counter in some sort of loop, you'll probably use that in multiple places in your code. And that's perfectly fine because each time you're using I, it's in a different loop, it's in a different scope, and they're separated from each other, so it's quite clear. However, if you are using names that are longer, that are more descriptive, and you're using those same names in many different places in your code, using them in places that are really close to each other, using the same name in nested scopes, then things start to get confusing, and I would generally recommend that you avoid reusing names in that circumstance. Generally, if you're picking good, long, clear names, this really won't come up all that often, especially if you're writing short functions and things like that. But especially while you're learning, I strongly recommend trying to avoid reusing names in your code unless they're very simple, clear names, like single character names for counter variables and things like that. So what's the correct answer here? I would say it depends on the name. Generally no, unless they're clearly different scopes. Okay, another thing that I want to make really clear early on, and this is going to be something we're going to be coming back to repeatedly, is that unless we say otherwise, unless you tell C++ to do something different, generally C++ makes a lot of copies of things, including copies of your arguments when they're being passed into parameters, and it makes a copy of the thing that's being returned from the function when it puts it into the whoever was calling that function's result argument, or result value. So, and why would you care that things are being made, that these things are copies? Well, generally you don't care, in that a lot of the functions, especially early on in this class, you're writing functions that only work as fundamental types, which means they're types that aren't particularly big. And copying, an int or a double or a long is basically instantaneous as computer operations go. However, later on when we start writing functions that take more complicated data types, the fact that it's always making these copies of things starts to get expensive. So you think about if you have the string that contains all of the text of Moby Dick or something, and if all you're trying to do is you have a function that tells you what the first word of that string is, copying that string to that function can start to get pretty expensive, especially if you call that function a lot. So we'll teach you ways later on in the class to avoid copies, but I just want to say right from the outset, the way C++ works is it makes copies of its variables generally. So let's look at a couple more examples of functions, and especially how functions interact with scope. All right, so here is another function. We have a bunch of includes and using statements up at the beginning, and we have our function definition here. We have this function returns an int, its name is reverse int, and it takes a long as an argument. And what does this function do? Well, it reverses the number by checking until the number is equal to 1. It's building a new number by figuring out what the last number is and then adding it to the back of the result. The exact thing that's going on here, you can work through. I recommend if the code here is complicated, and it's, to be honest, is mildly complicated, put some print statements and things in here to look at what these intermediate values are while this function is running. It'd be a good practice for how modular arithmetic works. But the point of this example isn't actually what's happening here. It's, once again, it's the big picture. What we have here is a function that we can use. And now, once again, I said this function is actually a little bit complicated in how it works, but if I've tested this function adequately, I can be confident that it performs well. And so then I can use it down here, and when you're calling your function, you don't actually have to care about the details of how that function performs as long as it does its job well. And so here I have a long that I'm filling from the console input, and then I'm calling this function on that, and then I'm counting the result of that value. Now the important thing to note here is that this function, notice that it changes number. It modifies number. Now you might go, wait a second, so here we have the variable number. Shouldn't this number and this number be the same? And the answer to that is no. These are variables that are in different scopes. You see that I'm declaring number here. What's the scope of this number? It ends right here, and this name, this number, can only be used in here. This number is a completely separate variable. It happens to have the same name, but it has actually no connection to the number here. This is a different variable that exists for the extent of the scope denoted here. Now, it just so happens that this number, the value of this number, is getting copied into this variable named number. They just happen to have the same name, but this variable is getting copied into here, and so this is actually modifying a copy of the variable, not the original. So when I print out this number here, this number right here, is unchanged. The function here cannot change this variable because all it gets is a copy. This is an argument. It gets copied into the parameter. Make sure that you're clear on the distinction between argument, parameter. Okay, another function. So here is another function. Here we just called it myFN, short for function. And what does it do? It doesn't really matter. It's mostly just using some variables that are declared inside to see out some stuff. It returns something called PyDiv. What's the type of PyDiv? Well, you can see that we declared as a double here, and that matches the return type for this function. And it takes a long num. And so down here we're calling myFN with some value that somebody typed in, and we're saving the result, and we're outputting what that number is. Now, once again, this num right here, completely different from this num right here. These just happen to have the same name. If I changed all the instances of num here to be like Josh, the code would do the exact same thing, and it'd actually get compiled to the exact same code as well. Okay, now one thing to note is that here, these are local variables. These are variables that are declared within a particular scope, specifically here within the body of this function. I cannot access those variables. If I remove this comment and I try to compile this code will not compile. Why? Because it will say name not defined. Where the heck is pi? Because pi is not declared in this scope. Pi is over in this scope. And so if I want to get access to pi, there's actually no easy way to get into the variables from this function. If I care about this pi, I should probably return it from this function, or use some static or global variables, things we'll teach you about later on in the class. So pi is not allowed to be accessed from the main function, nor is PyDiv, because once again, these are both local variables. All right, back to the slides. So, multiple choice question time. Are functions allowed to call themselves? Well, hopefully, especially those of you who took 231, you should know the answer to this is yes. And there's a fancy name for functions that call themselves. They're called recursive functions. And how they work, well, we'll be talking about those later, and we'll have them in some of our homeworks and things like that. Functions are definitely allowed to call themselves. And in fact, that'll be a very important principle, especially for later CSE classes.